Well, hello everybody, and welcome to another Sunday night short. And I think in all likelihood this will be another very short one. Got a couple of little things to show you over on the bench. Got a project for one of the scientists from Rothamsted, actually retired but still working on scientific projects. It's quite an interesting one, going to be a little bit of stainless steel fabrication work. And well, I'll just I'm not going to tell you what's coming up because I don't know at this point. We'll see how things go. So let's get on with it. Okay, well the first thing I've got to show you is a V-belt that I found doing a little bit of rearranging in the workshop the other day, and it's off a bit of equipment that you haven't seen yet. It might be a while before you do. It's got to get dug out of the corner and set up. Well, dug out of the corner. It's quite a heavy beast. I've moved it around quite a lot on my own, pushing it out the way. It'll get recommissioned. But I've got a rather nice cylindrical grinder, Myford MG12, with the full hydraulic auto traverse and auto infeed and everything. And this is one of the V-belts off the workhead. And as you can see, this has seen better days, or more accurately, probably better decades. But I just wanted to show it to you because a lot of people may not be familiar with the old style belt construction. You know, they're used to the rubber style belts. Well, this is canvas. And you can see the outer layers peeling off. And then you've got another layer. And then you've got another layer. And inside, it's made up a bunch of cords. And like I say, I'm just thought I'd show that to you because, you know, this is how the old belts were made, and in some ways they seem to run smoother and quieter than a lot of the modern belts. I went through a period on cars where certainly with the Lucas alternators, which were never renowned for being the highest possible quality, I was having problems with bearings on recon units failing. By the time you'd got the belt tensioned tight enough not to slip. And I solved that problem by changing from the automotive V-belts over to industrial ones, which had a much better grip surface. And I think these canvas ones used to grip better at low tensions as well. The belts seem to have got to get better again. For a while I thought there was a conspiracy between the people who made the belts and those who provided replacement alternators and water pumps. And another thing I found when tidying up was a bit of tooling I'd forgotten I'd got myself. And it's a nice bit of Starrett tooling, but this is superior Starrett tooling because it was made in Britain. And it, as the box said, it's a bevel-edged, straight-edged, and I'm going to have, let's see how wide we can go. Still not wide enough. But let's see if we can. I think you're going to have real trouble picking up the maker's markings, but I can tell you that it says the LS Starrett Company Limited, Great Britain, and you know, it's got the odd little bit of surface corrosion from storage, just a tiny amount. I got it as basically new old stock. I have no idea exactly how old it is. Again, you're not going to be able to pick up the markings because of the glare, but just here and here are the markings that show where to support it for the minimum amount of distortion over its length. I seem to recall I didn't pay very much money for this. Someone had obviously come across a bunch and were selling them off, and if I ever need to do any checking of surfaces for level, and I can for instance feel that this surface plate, which is not an engineering grade, it's like a printer's plate, is a little bit domed in the middle. I can just feel the way the bar's pivoting. So we'll put that away back in its box, and before I actually hide it in a corner again, I'm going to give it a little bit of Lanagard coating to protect it in his retirement, notably for you know, for third world countries. And the project he's working on is an extraction process for getting certain chemicals out of plant material. Now I can't tell you exactly what the chemicals are. Some of the processes are sort of public domain, but others are, you know, it's his retirement bonus is potentially going to come from some of these. But I can tell you that it's using a refrigerant as the extraction chemical, and it's a sealed system under pressure, kind of set up like a refrig unit, and he needs to maintain the level of liquid in one of the containers automatically, and the level changes depending on how much vaporization is occurring. And he's been doing it manually with a sight glass at the moment on a valve, which is a little bit haphazard and requires a lot of babysitting. And he wanted a means of detecting the level within the vessel and keeping it between a pair of set positions. So my thought was that we make a float valve, and we couldn't buy one because the solution is quite viscous because of the plant material, and a lot of the standard float type level valves would actually gum up, and a lot of the other stuff's not that happy about working at up to 150 psi. So I reckoned on a float valve, and I grabbed a reed relay from my drawer of parts, and this is a bit of the high pressure process tubing. I mean, this stuff's good for 1500 psi or so, so it's over the top for the job. But there are standard compression glands with flanges to put this onto the vessel, and I can get the reed relay down there. Ideally, I need to get two in here, which might mean going to a thinner wire. This is a Teflon coated hookup wire that I like for this kind of application. Though try stripping the stuff, it's a bit of a pain to strip the insulation off. And I came up with good old eBay. I found some neodymium rig magnets, and I was also given a little bit more stainless tubing, and this magnet is a really nice fit over there, and I know that it quite happily triggers the reed relay through all those thicknesses. So the plan is to make a float with the magnet around the inner tube. Okay, we got this thing in the 3-jaw, and obviously being tubing I can't hold it all that tight without distorting it. The distortion doesn't really matter in this case, you know, I'm only facing the ends, it's not a precision part in any kind of way, so I've got a fairly good hold of it. This end's pretty square, and the bandsaw's got a reasonable blade in it at the moment, fairly well adjusted, so you know, it's out by millimetre 40 thou out of square on that end. So I'm going to do this end first, which I know is a little worse, and we're at a, let's have a look at this. I'm not going to worry too much. It came from a bit of surplus exhaust tubing, stainless exhaust tubing, and I think it was close to a bend, so it's got a little bit of a curl to it. Machine's reasonably well. I'm just being a bit careful with it. That end about as square as it's going to get. Take that big bar out. Okay, I've roughed out a couple of stainless steel discs with the bench shear. I cut them, you know, fairly round, which means I should be able to get away with sitting them in the notches in the jaws. And then I can drill us a hole in the centre. Now it's running reasonably true. Open that up to 8mm. I want to be able to hold it on this little stub arbor that I've got hanging around to turn the OD, so I just need to, yeah, it needs to be a fraction larger. That was just a random drill I grabbed from the box. It's slightly undersized. Yeah, that's better. That's just a nice fit on that. So let's deburr that side, pull it out. And while I'm thinking about it, deburr that side, and I'll stick the other one in here and do the same all over again. I got this little stub arbor which was used for some other job. It's got a reasonable amount of surface area on there, so I'm hoping that I can clamp these up well enough. Yeah, we're going to need another spacer in there, that I can grip them and turn the OD. Okay, now I'm going to take this very easy because obviously it's an interrupted cut and I haven't got the best grip on it. But if we go slow, we should be okay. Okay, we're about 90% cleaned up on the OD, actually maybe a bit less on that one. I'm just going to go and get the bit of tubing and see how close we are to the size I want. Now we've still got a way to go, so they're going to clean up fine. Okay, that's a reasonable diameter match. Going to take it down just a tiny fraction more, and we'll call that done. Yeah, I think that'll do fine. I'm going to use a file to take these burrs off. Didn't want to do it with the you know, a chamfer tool because they're not running really true enough to do it properly, so easier with a file. So I've got the disc back in the 3-jaw, just using the notches in the jaws to hold it, because the thickness makes that a sensible way of doing it. And these need to get bored out to suit that inner tube. Slow down a little. course the hole wasn't quite on centre, but this is a very short drill bit. It's one that's been severely shortened, the web's thinned. And I'll swap to a boring tool. Come up in speed. Of course, being a thin disc, and particularly in stainless, it's singing like a good one. Let's just see where we've got to. And set the DRO. So I'm going to come, what did I say this measured at? I'm getting 13.81, so I'm just going to come straight out to that and see how we do. We're nearly there, so I'll just take a little skim cut. There we go. So I've just got that to do on the second disc, and we've got all the components other than getting the inner tube to length. Okay, so we've got all the various components now. I've got the inner tube and the outer tube and the end plates, and they're just going to go together like that and get welded up into the float. And then one of these neodymium rig magnets will go inside, and I haven't quite decided how I'm going to secure it in place. It may be I'll just use a little bit of epoxy. I'm going to call that quits for today.